Blacksmith. I'm working on the level 1 national curriculum for Urbana's Zoom program. And at this stage, I've been making tools and demonstrating how to make some of the tools. And I want to now show you how to do the heat treatment of the tools. We're using 4140 tool steel and relatively mild tool steel, 40 carbon. And so we'll be heating up and doing the annealing process. And then after that, we'll do the hardening and tempering process. The annealing, I show by bringing it up to a non-magnetic temperature, checking that, and then letting the metal cool down to room temperature, or at least down to about 300 degrees temperature. And that makes sure that there's no other metallurgical changes occurring within the structure of the steel. Once it gets down to 300 degrees for this steel, it's basically uniform and without any further change. So this is the round punch, and the very end of this is maybe a little magnetic, but letting the heat come from the center out here, and the center part is definitely not magnetic. So we're okay, and this will allow this to anneal down. And I'll lay it off to the side and let it come down to 300 degrees. This is a slot punch, and it's already been annealed, and we're going to check it to make sure it's up. It's up to temperature, and that means it's got to be above the magnetic temperature, so it's non-magnetic at this point. And so the next step then is to quench this end. So I have cooled off the end until the very tip of that is wet. I put it in the water about 1.5 inches and cycled up and down in the bucket. It is wet, and that means the end is below the boiling point of water. Now I'm going to temper, and we're going to temper by using the residual heat that is left in the punch and let that transfer into the end of the punch and warm that end back up to about 400 degrees. Now how do I know the temperature? I'm going to take a small broken grinding stone and scrape off the scale that's on there and make it shiny as best as possible. And then I'm going to watch the colors transfer down to the end of the punch. Okay, so if you can see in the light, the colors are blue back here, and they are slowly turning to a brown color out on the very tip of the punch. When it gets to a straw color brown on the tip out here, I'm going to go back in the water bucket and cool it off up to about where it's gray in this area. So now I'm at that brown color. It may be difficult for you to see, but believe me, it's brown. So we're back to the wet condition, and I did not dunk it in the water any more than I had to up to about 1.5 inches. I'm going to re-scrub it with this grinding stone. I would really like there to be enough heat in the residual part metal of the punch to be able to reheat the end all the way back to the brown color on the very tip. We can see where I ground it with the stone. It was picking up some turquoise and some peacock colors. So as those colors then progress, we can see the browns starting to form out in front of those brighter colors. This second reheat is not absolutely required, but it's really nice to do that. And technically the reason is that in the first process of quenching into the water bucket, there was about 30% of the steel that did not convert into the hardened form, and it's called retained austenite. When we reheat within the tempering process, it allows the retained austenite to transform, and then our second process that we're doing now is tempering that remaining 30%. So if we don't get the heat transferred all the way down, essentially there's 30% of the steel that could be in a brittle phase, and so we're just trying to, this is just a cover-all insurance policy to make sure we get the best result possible with the steel that we're using. Now bear in mind, this piece that I'm showing you here, we have not taken to the bench and filed off the edges. I see the roughness of the hammer marks, and since the very tip of this is hardened, our file is not going to be very happy trying to remove the hammer marks. So we may have to go to our 4.5 inch grinder or a belt grinder on the stand in order to actually remove some of those roughness. But you get the general idea of what we're trying to accomplish in what I'm showing you here. A little bit of color there. It's really difficult to pick up in the light right now, but it's doing its thing, and the steel's getting happier all the time, and that's important. We like happy steel. We don't like it to break and chip and fly off, hurt somebody, and destroy the tool. So this process of heat treat applies to all the tools that we just made. The round punch, the chisel, and this slot punch. Same process, same technique, and it applies to all of them. Curved chisel, if you choose to make that, also. Any tool like this, and especially in this relatively mild tool steel version, I use water. Some of the people might say, oh my gosh, don't use water. But this is a relatively mild steel, meaning there's not a large amount of alloy, and it will tolerate the water quench. And the other thing going for us is we don't have any sharp corners or nicks or anything that might cause a stress concentration point, and therefore the quenching in the water is less aggressive in terms of causing stresses and potentially cracking and brittle failure. So there's reasons, and they all work. Higher carbon content, higher alloy, I would go and use oil instead of water. Okay, thank you.